Hola! Here we go. Alright, so with this we have two cars that we're meeting back in the presentation. The grids below correspond to each of the slides. On each grid, draw two graphs of position versus time, one labeled A for car A and the other labeled B for car B. So car A starts at x equals 300 meters and goes right 10 meters per second. So we know that's a velocity because if we look at the units, meters per second is the unit for velocity. Car B starts at 100 and goes to the right 30 meters per second. Well, what kind of graph are we looking at here? Step one, when looking at a graph, look at your axes and its units. So we're looking at position and we're looking at time. So let's start with car A. We have the initial x and we have the velocity. Remember from the previous video, it looks like this velocity is not changing, right? So if our velocity is not changing, then we can have our y equals mx plus b because we should get a straight line. Constant velocity will give us a straight line on a position versus time graph. We know this from the lab. We also know this because the slope of position versus time is our velocity. The x-axis is our time. The b is the initial position. And then finally there's our final position. So this is our basic equation for constant velocity. We can graph that. It's in slope-intercept form. So let's start at 300, which is going to be right there. And then it's going to go right, so positive velocity, so it's going to increase its position away from 0. So we're going to go up 10. What is this? 1, 2, 3, 4, 5. Okay. So we're going to go up 10 and over 1 second. So right there. Up 10 and over 1. Up 10 and over 1. Up 10 and over 1. Please take better care to graph this. Up 10 and over 1. Up 10 and over 1. Up 10 and over 1. Okay, so there we go. Now we can have a straight line. Should have a straight line that will connect them. So there we go. And we'll go ahead and label that as A. Now for B, we're going to use the same thing. It doesn't look like the velocity is changing at all. We're starting at 400. Oh no, we're looking for where the cars meet at position 400. Excuse me. So car B starts at 100 and then goes right 30 meters per second. So our slope, because it's 30 meters per second, our slope is rise 30, run 1. 1, 2, 3, run 1. 1, 2, 3, 1, run 1. 1, 2, 3, run 1. Let me pause this because... Alright, so after fixing my graph, here we go. You should get something like this, where we have green is A and blue is B. Car A starts at 300, goes left 10 meters per second. So if we're going in the opposite direction, then we're closer to 0, or the origin. Car B starts at 100 and goes right 30 meters per second. Okay, so they're going in opposite directions. So this is very reminiscent of our lab. Starts at 3 and goes left. So it's going to be a negative 10 meters per second. So that means we're going down 10 and to the right 1. That'll give us a negative 10. That could be our slope. Let me pencil that in here. Alright, so after graphing all that, we've got line A here, line B there. Line A shows that the car is moving in the opposite direction. Not with a velocity that's slowing down, just in the opposite direction.